Hello, everybody. Our project is responses to the COVID-19 parking lot uses to the COVID-19 pandemic. We are Bill and Natalie. Our motivation for this project is the oversupply of parking in the U.S. Parking lots are very much part of the Marney landscape, with more than 8 spaces for every registered car. And finding the right amount of parking is very difficult to balance, and there are many implications of having too much parking. There are environmental implications of too much runoff, how it contributes to urban heat island effect, it lowers densities of our cities and contributes to the very unsustainable urban sprawl. And there are also economic implications, like how they take up very valuable space, and there's opportunity cost of the productive uses that could have added to the vitality of neighborhoods, such as apartments or businesses that generate higher tax revenues to the city than a bunch of asphalt. Next slide. So our research question is how did COVID-19 impact parking lot occupancy in Durham? Understanding the changes and trends can help us make informed decisions on parking lot arrangements. And for example, if you find that parking lots are significantly underoccupied, this is possibly an opportunity to repurpose the space for other uses that could contribute positively to the city of Durham. Next slide. So one-way parking lots can be reused in Durham. As an example is for affordable housing, which is a big concern for the city. And these are just 2 example proposals in the last couple of years related to reusing parking for housing in Durham. Next slide. So our lots are primarily, we're focused on surface lots in Durham, and we're looking at commercial parking lots in front of places such as shopping malls and supermarkets, as we predict those would have have most changes due to COVID. Next slide, yeah. So we're using satellite imagery to run our models to collect the vehicle data, and we're using images from Google Earth Pro. Above is a timeline of the timestamps that we have as our data from Google Earth Pro.
In addition to satellite imagery, we'll be using computer vision models to detect the vehicles that are present in our images. In our application, we'll be using You Look Only Once, or YOLO, which is the state-of-the-art object detection algorithm. We'll be using 2 metrics to evaluate the performance of YOLO, precision and recall, where precision refers to the predictions that are vehicles out of all predictions, and recall refers to the predictions that are vehicles out of all vehicles that are present in the image. Currently, we're able to achieve 92% precision and 72% recall. And we created a stacked area graph for the number of parked vehicles over time. And we can see that there is a decline between 2018 and 2019. However, we have yet to see a significant sign of recovery after the COVID-19 lockdown yet. And we also created a breakdown of occupancy of each individual parking lot. And something we noticed is that for larger parking lots, which have more than 1,000 parking spaces, the overall occupancy is generally lower. And we also noticed that the occupancy for most parking lots are lower than the ideal occupancy rate, which is around 85% to 90%. We definitely would need more timestamps to support our thesis, but with Google Earth Pro, this is what we have so far. For our future works, it will be mostly just to obtain satellite imageries from sources with more timestamps available, such as WorldView 2 or WorldView 3. And we'll also want to develop a new training data set so our model can perform better in detecting all the vehicles that are present in the image. Thank you for your attention.